Section 3.1 is on solving one-step equations. Before we start solving equations, let's look at what we've done in the past. You have done in the past what we called adding like terms. So you had an expression like 5w plus 12 minus 4w, and the directions said simplify. And what you did was add like terms. So we have a 5w minus a 4w, and since they both have w, you add them together. So we have 5w minus a 4w, which we just have w left, and then plus your 12. And that was your answer. That was simplifying this expression. So now we're not working with expressions, we're working with equations. So now we're going to have an equal sign thrown in there. So here we have x plus 3 equals 7. And the directions say solve. So that means we need, in the end, our variable equal to a number. We're supposed to solve for this variable x. So find where your variable is. Ours is right here, and your goal is to get it all by itself. So we need to get rid of this 3. How we do that is, to move it to the other side of this equation, over here, we have to do the opposite operation of what's happening. Here we have a plus 3. So we're using addition. The opposite of addition would be to subtract. And I know if I subtract 3 from this 3, 3 minus 3 is 0, so it goes away. Which is good, it's what we want. We want x all by itself. But whatever you do to this side, you have to do to the other side of the equation. We have to keep this balanced. If we don't, then it's not true. So I'm going to also subtract 3 to the other side of the equation. So over here, these 3's canceled, and I just have x equals 7 minus 3 is 4. So to check your solution, you can always check your solution. If you plug in 4 for x, you should get a true statement. So if I plug in 4 for x in that equation, and I do 4 plus 3, 7 equals 7, and that's true. So my answer is correct. So you can always check your solution. So here we have x minus 2 equals 3. The directions again are going to say solve. To get x all by itself, we need to get rid of this 2. It's being subtracted, so the opposite operation would be to add it to both sides. Whatever you do to one side, you have to do to all sides. 2 minus 2 is 0, so that goes away, and you have x equals 3 plus 2 is 5. And again, I can check my answer if I want. I can plug it back in, and 5 minus 2 does equal 3, so it's correct. The next one, again, the directions are solve. I have negative 6x equals 48. I need to get x all by itself. When numbers are written right next to each other, it's like multiplication. So I have negative 6 times x. So the opposite operation of multiplication would be division. So I'm going to divide by negative 6, and I have to do it to both sides. So my negative 6 cancels out, and I'm left with x equals 48 divided by negative 6 is a negative 8. And I can check my answer by plugging in negative 8 for x to see if it equals 48, and negative 6 times negative 8 does equal 48, so my answer is correct. So now I'm going to throw some fractions at you, but the rules are the same. Here I have 1/3 times x equals 2. I have a third times x, so the opposite would be to divide, but instead of dividing by fractions, because this looks just sloppy and ridiculous, remember that you can multiply by the reciprocal, and that's the same thing. So I can multiply by a 3 on both sides, because these 3's will cancel, because one's on top and one's on the bottom. So I'm left with x equals 6. And again, if I check my answer, 1/3 times 6 is 2. So my answer is correct. So here's the same thing. I have 1/7 x equals 3. If I want to get rid of this 1/7, I can divide by 1/7 But instead of dividing by a fraction, I can multiply by the reciprocal, and that's the same thing. So I'll multiply both sides by 7, so that cancels, and I have x equals 21. I want you to go ahead and do these three in your notes. We have r minus 4 equals 8, 1/5 x equals 2, and 9x equals 3. I want you to solve for all these variables in your notes.